Okay, so welcome. In this little tutorial video, what we're going to be doing is actually creating a price response function for different soda cans or soda brands. So in Greece, I've got some data for different soda pop sales for various brands and different kinds of containers over all kinds of different geographies. And what we're going to be doing here is actually creating what's called a price response function. So I'm over here. I'll be writing some little cliff notes. Let's go ahead and start off with just a little quick refresher to make it to remember exactly what we're talking about. So in basic micro, what we have so far is we have prices and quantities up here. You know, you've got your supply upward sloping. We've been talking about demand downward sloping, right? There's our demand curve. Okay. Here, I want us to just really pay attention. It's just a really simple way of flipping things around. So this is what we see in our textbook, okay? Our standard microeconomic textbook. You have prices on y-axis, quantities on the x-axis. Now, when we look at it in functional form, we have, and here, price is a function of Q, okay? Which means if you know anything about functions, getting back to just mathematical, this is basic mathematical kind of, I don't even know what they cover this in, but it's what is a function? A function is a thing. It's where actually it takes one value and it has a singular mapping to the output. So remember, in a function, remember there's like that vertical line test. So this would be a function, but you know, if I were to draw another line that goes like this, that's not a function because it fails the vertical line test. Now here we have an x and we have a y. See, so there's like y is a function of x. So in this case, a function is such that if I give an x, it returns a unique value of y. That's what a function is. The vertical line test, again, just to remind you, in the pink sort of curve, if I pick an x, I get back multiple y's. Okay, failure right there. So that's what we got going on. Just to remind you all what a function is, and we've specified in our demand curve, price is a function of Q. Now, what we're going to do is really just flip it around because and we're just going to rewrite this as Q is a function of price. Okay, that's the quantity demanded is going to be this function of price, and that's what we're actually going to model when we talk about price response function. Okay. Price response function. There it is. Just as simple as that. Okay. So price response function. So instead of doing a P and Q, what we'll do is we're just going to model it as a Q. It's a function of P. And guess what? It's also still going to be downward sloping because we have a negative inverse relationship. So that's what's going on. I just want to show you the background theory about how we go from demand to price response function. It's just really about flipping the axes. That was a long little tutorial about just flipping the axes. Okay. Could have just said it straight like that, but I wanted to give you the full underpinnings. Okay, so now let's go ahead and do this. Okay, so let's go ahead and first thing you're going to do is take in your data file, which so if we go new dev, and no, it's not a new dev. I have COVID right now. It really sucks. I gotta tell you that. So I'm a little bit loopy, pardon me. So here we go. We're going to go, I'm showing my whole file folders, but whatever. We're going to go into, where is this? Forecast demand and this output file. That's going to be your data file. Okay, so just import it into Tableau, just that easy. I suggest just running the interpreter. The interpreter, just as simple as clicking the button. It's going to take a little while to think because this is, you know, it's a moderate sized file. Okay, and I'm just going to zoom and blow this window up. So we see what we have here. So there we go. So now we have this, the data's loaded. You see we've got this month, it's actually monthly data for different shops. And what we're measuring are the prices and quantities of various types of brands. And also they have plastic. Some adult colas are in different types of varieties of containers. So we have all this data. It's nice and rich. We've done the interpreter. Now we can just jump straight to the worksheet. Bada bing, bada boom. And so what we're going to want to do first off, remember, now here we have our y-axis. Here's our x-axis. So what do you think? If we want a price response function, now here's your quiz. What should go on the y-axis? Huh? We're looking for quantity is a function of price, right? So where's my quantity? There it is. Ta-ding. And look, it comes in the rows. And where's the price? Let's go up here and bottom. Oh, wait a minute. I only have a single dot. What happened there? Well, actually, there's a couple things going on here. First, the first thing is that we have to look at our measure of price and quantity. Here it's a summation. So summation means add everything up. Does it make sense, first off, to add up all the prices in the data? So we had all the observations of sales. Does it make sense to add up all prices? Not really. I think what's probably a better measure? I'm going to go with an average. Does that make sense? So if you're recording prices of things sold, why would it ever make sense to add up the prices of the things you sold? If you're talking about the price, trying to get the price of something, that just doesn't make sense. You want maybe because the price of, say, an adult cola is going to change over time. It's going to change like by season. It's going to have a lot of different changes. But it doesn't make any sense to add them up. So let's just think about prices in terms of averages. Plus, we have different measurements across different stores too, right? We can add up quantities though. That makes sense. Add up quantities, average price, add up or some quantities. Okay, now we're there, but we still have a dot. Okay, so how do we get this? Well, first off, we need to start looking at this across some different dimensions. So we can look at it maybe across, I don't know, say like a time dimension. Let's try that. So let's go ahead and grab, date. And how about we just take date? Oh my gosh, I'm not doing so great. And throw it in details. What's that going to do? Okay, that threw it. I just dropped date, threw it in the details. Now we're getting a scatter plot. You see? Okay, so these are obviously by different years. Now, when I click on, so what you're going to want to do again, just take date, throw it into the details, and then you're going to get a point. Now, this is a point for the prices and quantities for every year. Now, remember, we have monthly data, so we could do better than that. I want to show you something, though. If I just go click from year to month, what's going to happen? Oh, wow, that's really strange. Now I just get it. I'll see there's February, January. These are the one. These are actually for all different months. But guess what? We also have months and years in this data set. So we don't want to just do it by month because then we're actually looking at across all these different years. So actually what we want to do is come down to this bottom category here. And you see where it says quarter is Q2 and year, also month, May 2015. This is month and year. You see up here, it just has month and year. And now we have month and year. That's the one we want. So let's go ahead and grab that. That's looking a little better. Okay, still looks nothing like a price response function. It just looks like a big scatter plot of all these kind of data points. What's going on? How do I pull this apart? Well, first off, we have a lot of different brands here. So we need to isolate some of these brands. So we also have different capacities. So first off, let's do a filter. So let's filter out and let's just look. Actually, you know what? I'm not going to go by capacity. Let's go by container. Where's container? See, it's got the ABC. That's a categorical variable. Drop it in the filter. Okay, how about we look at glass? Okay, the old school. Okay, glass. Who likes to drink soda out of glass bottles? There we go. So soda out of glass bottles. Okay, now we got all the different brands still in here. So now with brands, I can do a couple different things. One thing is I could do a filter and just look at a specific brand. So if I want to just pull it off and look at Gazoza, okay. Oh, look at this. Now I'm starting to look like I'm getting a downward negative correlation that's starting to look like if I were to fit a line in here, I might get something that looks like either a demand curve or a price response function, right? That negative slope is starting to become apparent now. You see it? You see it? Huh? You see it? Okay, let's take Gazoza out of there and let's go for the big bucks. Okay, let's go ahead and take brand and let's throw it in the rows and see what happens. Look at that. Now I got the scatter for all these different guys. For adult cola, Gazoza, Kinder Cola, Lemon Boost, just like that. Or I could stick it right up there like that. And when I look at it, I'm starting to see that I do, in fact, see a fairly consistent sort of negative slope that's appearing in all of these. This is looking good. Okay, this is starting to look good. I don't really like how the scales are all the same. The scales really should be fitted. I need to think about how to do that in Tableau. That's something I need to learn. Okay, well we're going to skip that for now because right now we can kind of see that. I mean, you see what my point is? Actually, the scale of, say, Gazoza, it has a range that's between, I don't know. I mean, it's between like this range is where all these dots are falling. So I don't need all this extra space over here. And actually, if I just got rid of it, you would see a lot more clear the downward slope. I think it would actually flatten out and become more pronounced. Right now, it's looking pretty vertical because everything's pretty crunched. And that's another point too, is that actually the scale, and I'll bring you just to a critical point, is that actually just the scale at which you look at something, which you can think of as like, right here, we got a lot of extra space. It's almost like we like zoomed out, like we're looking at it from like 5,000 feet. We're looking at the scatter from like an airplane. So when you look at something from an airplane, actually the trend lines can become compressed and start to look as if they're not trend lines, when actually if you zoom in, you might see a more pronounced one. So, just something to think about, okay? Is that the scale and where your zoom is actually gives your eye some tricks about what you think you see in terms of patterns. Okay, so let's go. Okay, let's just run with this now. One thing I could also do is what happens. I just want to show you this. What happens if I threw it down the colors? Hey, that's even crazier. Look at that. Look at that. I got Gazoza. I got all these guys. I can really start to see. And I can also take Brand. How about Brand and throw them? Right, let's get even really crazier. Look at that. Now, what I want to do is actually fit. Okay, now let's get to the brass tacks of what we're doing here. That was a lot of playing around. That's what you call playing around with data. I geek out on that stuff all day long, all the time. It's just what I like to do. But so let's just go back to analytics. We're going to fit a nice regression line through here with a simple linear regression. And bam, you just click on it like that and you get a regression line. And look, it gives you the equation of the line. Okay, so this is quantity equals negative 2, what is that? One, that's 203,493 times the price. So that's the equation of the line right there. Q, just to make this explicit, okay, I want to make this really explicit, is I'll take it, I don't know, maybe something not so crazy of a number. I'll do it for Kinder Cola. Okay, Kinder Cola. So here we have Q is equal to negative 80639.5. And I'm just going to call it times P. It's average price, but I'll just call it times P plus 203,770. That's my equation for my line, okay? Remember, the equation for my line, y is equal to mx plus b. Okay, or we have relationships like this. Okay, that's what we have gotten, right? Remember, quantity is a function of price, y is a function of x, y is mx plus b, m is the coefficient on the slope term, this is my intercept term, and so that's all we need as far as calculating the basics of elasticity. We are almost there, folks, because here it goes. Check this out. Now, what if I was going to ask you something like, what's the elasticity? So at this point, so what's the point of elasticity? What is my point elasticity here? Do you see? Average price of 1.367, a quantity of 87,623. You see it right there? Do you see that right in the little side box? Okay, so my question is then, what's the point elasticity of that? So this is what I'm going to show you how to calculate. Point elasticity is actually going to have, so you learned about how to calculate arc elasticity maybe in the textbook. That's very kind of back of the napkin. This actually gets the job done, okay? So elasticity here, point elasticity, not arc elasticity. We're going to define this again. It's the same as this percentage change in quantity for this percentage change in price, okay? And actually, what this is going to be also equivalent to is actually the change in quantity for a change in price times the actual price over quantity, okay? I could decompose this a little bit if you wanted me to just give you a little intuition there. I mean, I'm just kind of cramming a equation down your throat and telling you to chew on it, but I mean, that's kind of the equation. I give you like a little intuition. So let's just look at this percentage change in quantity. Look, what if what if we looked at this somewhat equivalently as the change in quantity over the quantity itself. So in other words, like if I went from say 100 to 105, that'd be a 5% change, right? How'd you do that? Well, the change in quantity was 5, okay, over 100. You see, that's how you got it. So there we have for the percentage change in quantity. Similarly, you can have this kind of idea, this percentage change in price, kind of go into this change in price over P, okay? Now, if I just take and I put these in the equation like so, remember when you divide by a fraction, you multiply by a reciprocal, and we kind of get out of this. So we have change in quantity, and I'll write big fraction over quantity. I'll put it over here, see? And remember, multiply it by the reciprocal. In other words, I flip this and multiply it, so that becomes a P on the top, and I change it P on the bottom. And there you go. Okay, that's hopefully convinces you. Just gives you a little bit of intuition of I'm not just trying to jam an equation down your throat. So the nice thing about this equation, though, is that this little guy right here, guess where he comes from? Okay, this one is going to be our slope term. Yay, we have that from the data. What else do we have from the data? Okay, well, what else we have from the data are the actual prices and quantities at a given point. So here I told you the average price was, remember I said the average price was equal to 1.1367, and our quantity is equal to 87.623. Those are the things that you actually observe when you're in your business, okay? So you actually observe those are the prices and the quantities that you're currently selling at. That's what you're going to observe. You could make this a lot more sophisticated. I'm just trying to give it to you in the brass tacks way, but that's what you're going to observe. And so look how you plug this in. It's real simple. Look, let's do this. Let's do this calculation right now. How about it? Let's do it. Huh? Let's do it. So we got the purple. I'll keep true to the color. How's that? Here we go. Purple. Zoom. How about that? Negative 8063. I was going to round up. I realized it's a 5. Okay, I'm gonna round down. I'm just gonna call it. I'm just gonna cut it off at a whole number right there. I'm not gonna carry around a decimal. Okay, that's a math bad right there, but whatever. There's my slope. Okay, there it is. And now I just need times the P over Q times 1.1367. This I will write out over Q because I want to just make sure my rounding is good. Okay, so that's over 87,623. What does that actually equal? Go ahead and calculate it. And then the question becomes now, should I increase or decrease my price to change my revenues? Okay, that's what it becomes. So let's go ahead and calculate it. I need a calculator. Shoot, I got all this fancy stuff and I don't know what my calculator is. Okay, so that's no good. Calculator. Okay, come on, calculator. Let's see what we got. 80639 times 1.1367 divided by 87623 equals 1.046. And you know what? That's close to 1. It's a little bit bigger than 1, so we're just going to call it elastic at this point. I'm dodging a really big kind of thing in statistics, which is that we have some uncertainty in this model because guess what? When we did our regression, it was with error. I'll show you that in a second. We're ignoring that, sweeping it under the rug. And right now, I'm just going to take this one. I'm going to say this elasticity is equal to, elasticity is going to be equal to 1.05. Okay, I'll just call it that. And that's going to be greater than 1 in absolute value. That is actually a negative sign. I dropped the negative when I did my calculation. You should know it. It's right there. Okay. So, but I just looked at, I did the absolute value. I hope you just appreciate that. Okay, so the thing about it really is this. It's that, and I said, look, I said we have error. Do you notice that, look, the line is our prediction. How many dots are actually on that line? There's dots actually on both sides of the line. We've made errors in our estimation. Our line is not a perfect model. There's no such thing as a perfect statistical model, or else it's just not a statistical model anymore. So the thing about it is that you can have tighter precisions and higher accuracies. We're not going to get into any of that. We're just going to sweep it all under the rug and say, okay, we're going to take this as what it is. Okay, we won't get into that level of kind of inference, but so because with the main thing we need to figure out is this elastic or inelastic? Well, it's greater than 1. That means elastic. Okay, what does elastic mean? What does it mean when it's greater than 1? Remember, what does that mean? That means that the quantity effect. Look, that means that for this fraction to be bigger than 1. That means the numerator has to be bigger than the denominator. That means the quantity effect dominates. Now remind yourself, what is total revenue? Total revenue is equal to, look, price times quantity. Okay? So now we have to turn to the question at hand. And this question was, if we increase, so if the prices go up from here, what happens to our revenue? Well, we know that as prices go up, that on the total revenue side, this would have a positive effect on revenues because we're collecting more prices. But at higher prices, there's less demand, so there's a negative effect on the quantity side. So we know that. Okay, so look, which one dominates though? It's elastic. We know the numerator dominates. That means the negative effect dominates. That means that raising my prices will hurt my revenues in this situation. If I'm at a price that and quantity and everything else that we've calculated would suggest that actually we have an elastic curve and that raising our prices would actually hurt our revenues. So you can also flip the script and say, okay, well, look, if I go prices go down, well, prices go down, lower prices, I'm kind of hurting my revenues because I'm charging less per unit, but I'm going to sell more units because, lower price, you sell more. So I'm going to gain more quantity. And so I'll gain some revenues there. So look at what's going to happen there. What's going to happen to our revenue? Hopefully you see now, and I don't have to say it, but I'll say it anyway, is that you see that the quantity effect dominates. The positive outweighs the negative on total revenue, and therefore lowering my price increases my total revenue when my demand is elastic, and I can actually calculate that and compute all that. So in summary, okay, what you're going to need to know how to do is, one, load the data into Tableau. Okay, I'm not sure how tricky I'm going to get with you. I'm going to have to get a little bit tricky. I mean, I'll show you a couple of tricks and things I can do about this, but you have to load it into Tableau. You'll have to do a regression. Okay, you'll have to get these different lines. And then what I'm going to do is I'm going to go ahead and pick a point. I'm going to pick a point, say right here. So I'll give you a point. I'll give you a price and a quantity. I won't make you find one of these dots. That's just too mean. Okay, I'll give you a price and a quantity for a specific, say, brand. Okay, and a certain container type. And I'll ask you, what's your managerial decision? And I'll ask you to support it. And so you'll have to tell me, with the managerial decision and the metric being, you're going to optimize your revenue. That's what you're there to do as a manager. That's what I'm going to tell you to do. There's other things that you could be doing, but that's what I'm going to tell you to do. Okay. So optimize your revenue. Go ahead and do that. And I'll say support it. I'll say, okay, this is the price. This is the quantity of Lemon Boost cans. Hey, what do we need to do? Do we need to increase or decrease our prices to max our revenue? That's what I'm going to ask you. I'm going to ask you to back it up. So what you're going to need to do is create this little tool that I just created here, create that, and then you're going to have to go through and calculate and back it up. You'll need to get the slope off these lines and back it up. Okay. I wanted to show you that. Look, I could throw a kinks in here. Okay. What if I said we're looking at the demand in these different brands, say for certain years. So I could look, let's go back to the data, and I could filter. Look, I could filter. Look at this. I can add more filters in here. I could look at I could look at just the ones in Athens. Oh, look at that. Now I've got it. Now I've got the demand curves in Athens. And I want to tell you something really quick too. If you're going to do demand estimation and you've got geographic data, use it, because guess what? The demand's probably going to be different in different geographies. You're going to find that out. In fact, let's check this out. You want to see something? Hey, check this out. What if I take this out right here? What if I took? Where is that? Where is that? Where is that? I'm a little COVID loopy. If I brought it down like that. Ooh, look at that. Now I got brands and I got cities. So I got brands, I can cross cities in this graph. Look at that. Isn't that cool? You can kind of see how the elasticities change across cities. Look at that. That's actually kind of cool. I mean, how can I see that? Look, in Lemon Boost, look at the slope. Negative, what is that? It's got a 0.5 on the end. I wish they didn't do that. Just whole numbers. Kind of confusing my COVID eyes. That's like negative 55,000. Okay. What if I come over here? That's half of the slope, negative 28. Well, not quite, but it's close. So slope isn't necessarily just the measure of elasticity, but for specific price and quantity, which these both share, if you had the same price and quantity and you had these different slopes, then yes, we would be talking about differences in elasticities. And what does that mean? That means that which one of these is more elastic. That actually means that Larissa has a more elastic demand for Lemon Boost, okay, than is in Athens. So what does that mean? So when it's more elastic, that means when demand's more elastic, that means there's more competitive markets. That means there's closer substitutes. That means they have less price authority in Larissa. That means if Lemon Boost, it looks like they got a stronger grip on the market in Athens. Looks like they're kind of losing their grip in Larissa. So you know what? If they're going to do some marketing and they want to just boost up their weakest points, you might look for the places where the demand is more elastic, because more elastic demands mean that your pricing and your branding is just not really differentiating yourself sufficiently from your competition. So that's probably where you want to like focus. If you're like a campaign manager, that's what I do right there. Okay. That's the whole point. And so hopefully that just like adds a little bit of clarity and some ideas to what's going on with this kind of data set. I think it's pretty cool. Hope you enjoy it, and that's it.